Okay, Year 12, let's look at example 2. Now to start with, let's rewrite this function so that it's d by dx of 2x squared plus 3. Remember, when you take the square root of something, it's the same as raising it to the power of a half. And now let's apply the chain rule. Bring the power to the front. 2x squared plus 3 times it by the original function. Take 1 off the index, which becomes to the power of negative a half, and then multiply that by the derivative of what's in brackets, and the derivative of 2x squared is 4x. Let's multiply these terms together and bring them to the front, so we end up with 2x times 2x squared plus 3 to the power of negative a half. Let's tidy this up and leave it in the form that it was presented to us in. So that becomes 2x over, remember when we've got a negative indice, we push that to the bottom, and on the bottom we can write 2x squared plus 3 to the power of positive 1/2. Now, remember, raising something to the power of a half is the same as taking its square root, so then we'll end up with 2x over 2x squared plus 3 and the square root of all of that. So this is how we differentiate this function, and we end up with this result. And just a reminder that if we were to start here and wanted to know the original function that this derivative came from, this reverse process is the process of integration. So if we were starting with this integral, we know if we integrate this, we should end up with this result here. And that's exactly what's being asked of us in this next question. So if we want to integrate 2x over root 2x squared plus 3, we can see from what we've done in part A that if this is the derivative of this original function here, then the integral of this must be the primitive that it came from. So in other words, the integral of this result here will be the square root of 2x squared plus 3. Now remember, this is an indefinite integral, so we need to keep in mind that our final solution should include a constant of plus c. Now we're going to use this result from part A and the result from part B to help us with this B part 2. So remember, I mentioned to you in the previous example, this is a differentiate, hence integrate type of question. So let's think about what we know. If I changed this, I know the integral of 2x over the square root of 2x squared plus 3 dx. I know what the result of this integral is. But that's not what the question's asking. I just can't take this question and change it. So I will need to consider putting something out the front such that when I multiply a constant, I can only put a constant out the front of an integral sign, because anything with an x needs to be integrated, and that needs to happen after the integration, after the integral sign. So I can only take a constant out here. And what I need to consider is what constant times 2x will give me a result of x, or just 1x. And that constant will be a half. If I take a half and multiply a half of 2x, the result from that is just x. And I know, that the result from this integral here is the square root of 2x squared plus 3 plus my constant. Now, a half of the square root of 2x squared plus 3. Remember, in the previous slide I talked to you about if you multiply a half times a constant, it's still going to be a constant. We still don't know what the value of that constant is, so I'm just going to, rather than writing a half c, I'm just going to write plus my constant c. Okay, I want you to take the time to look back over that, replay the video if you need to, and make sure that you understand how to get the result here in B part 2. we needed to differentiate first and then use the result from our derivative to integrate the result in part 1.